Hi. It's great to be here in New York City. I'm from a completely different time zone in the Middle East, and I'm going to talk about neurocinema. So when I was a young student, I was particularly inspired by these two books. So on the left is Janet Murray. She asked, what would it be like? Can we have Hamlet on the holodeck? Can we have an artistic masterpiece on future video game, virtual reality technologies? And then on the right, there's Rose Picard, who talked about effective computing. What would it be like to have computers that can recognize and express emotions? And then, for me, it was obvious that what I wanted to do is put these things together for my PhD and create movies that respond to our emotions, choices, preferences, desires. Obviously, even today, 20 years later, it's quite a challenge, but at that time it was a challenge. But we do have such a technology because we know that dreams, at least, can relate to our personal memories, preferences, etc., and unfold stories. And so I went to the psychology department in Tel Aviv University and said, well, can I have a skin conductance device, a digital one that I can hook up with virtual reality? And they said, yes, but we know we have only one device. It's really expensive. Why don't you practice on this analog device with ink and paper? And so at that time, it was a bit tricky to connect this to the virtual reality. I ended up doing my PhD on a slightly similar topic, but different. But then, a few years later, I was fortunate to do a postdoc in London working with Mel Slater, by far one of the most interesting scientists doing virtual reality. And we had a lab with all the equipment, and we were able to do several projects, especially some in-between projects. So this is an example of a collaboration with an art student, Kana Suji from the Slade School of Arts. And she had this project called Dream Products, where she would buy your dreams. So she'd give you £1, and in return, she has the royalty for the stories that you dream at night. She models the best in a virtual environment. And we hooked up to do what we call Super Dream City, which was an immersive virtual reality experience in the cave. This is a stereoscopic projection on the 3 walls and the floor. And this was, you were floating inside the best of Kana's dreams based on your skin conductance, which is a measurement of stress, arousal. So this worked as an amplifier. Essentially, if you came with a relaxed state, then our system would try to amplify that state and take you to the more relaxed dreams. This is the example on the left, for example, using tranquil trajectories flying around the dreams. If you were more agitated, stressed, it would take you to the annoying dreams, maybe on the right. This was an industrial zone with very annoying sounds. And so we also tested scientifically whether you can take people and lead them to 2 different physiological trajectories. And my favorite was actually these broccolis. To be honest, I don't remember by now if these were positive or negative, but it was an amazing experience to fly in between the folds of these broccolis. And incidentally, I was surprised recently to see that, this movie Inside Out. So they also had dreams about broccolis. I'm not sure what it is about broccolis and dreams. Definitely a question for future research. Anyway, so we were able to do even more than that by teaming up with Gerd Furcheler, one of the leaders who came up with one of the more interesting paradigms in brain-computer interface. And this is work with Robert Lieb, his student at the time, based on motor imagery. So you imagine your hands or your feet, and we can detect that. So in brain-computer interface, the idea is simple. We use a bunch of technologies, signal processing, machine learning, to try to extract some information from your brain signals and in real time. It is limited, but we can do that. And it's very far from mind reading or thought reading, but we can extract some thoughts or mental patterns, distinguish between them. And then if we can do that, then we can connect it to any type of device or application, essentially. And in this case, we connected it to virtual reality in real time so that you would control the virtual reality with your thought. And we did several studies, including, of course, navigation in a virtual street, and even the first ever study where you control an avatar by thought. So you imagine your hand and your avatar waves their hand. You imagine your feet, the avatar starts walking, stuff like that. This raises, of course, many scientific questions and also has useful applications, such as, for example, a tetraplegic patient, Thomas, was able to perform tasks, a simple task, but with very high accuracy in the cave using his thought alone. Now, this was all based on EEG. EEG are these electrodes that you place on the scalp, and these are subject to what we call the very low signal-to-noise ratio, very noisy signals. And more recently, I was fortunate to collaborate with Professor Rafi Malach from the Weizmann Institute, who has access to an fMRI scanner, and this is work led by my student Ori Cohen. So here's an example. So you are in the fMRI scanner, and you see your avatar, jump out of the fMRI scanner and start exploring the world. And this is, you are controlling this avatar by thought. In this case, the avatar goes and, explores this tropical island. And again, using the superior spatial resolution of the fMRI, we were able to do more intricate tasks than you can do with EEG. As another example, controlling a humanoid robot. This is in collaboration with Abdel Khedar's group in Montpellier in France. So in this case, the subject is in Israel. The brain scan takes place in Israel, and controlling the humanoid robot by thought, and the body or the humanoid robot is in France. And you have to perform simple tasks such as, again, navigating and maybe finding this red kettle that you see in the middle, which we hide in the room. So all this is possible. But then the question is, can we also have these more implicit, subliminal control of virtual reality or content experiences? So this is work by student Jonathan Giron in collaboration with artist Miri Segal. And what we did in this project is people basically, we turn off the light, there's music, so you kind of find yourself in a deep space with stars moving at you. And some of these stars respond to your brainwaves, respond to your preferences. So the system knows which star you prefer, and in that case, the star could start moving, and if you attend to it for long enough, it would kind of explode in a nice way in your face. And this actually worked so well, it works so robustly, even with EEG, because it's based on an effect called SSVP, Steady State Visually Evoked Potential. Anyway, the idea is that this works so well that we could allow people to perform this task unconsciously. That is, we told them that they see a movie of stars in space, and without knowing it, they were controlling the stars in the application. So they were unconsciously controlling the content and choosing the stars that would move. And this allowed us to ask some very interesting questions about implicit learning of BCI, brain-computer interface control, and similar questions, which of course I will not have time to discuss today. But this is just to give you a flavor that it is possible to connect the brain to virtual reality, but we are just scratching the surface. I think there's much more to do. So virtual reality has been termed, the ultimate display, okay, by Ivan Sutherland back in the 1960s. And of course, brain-computer interface, I see it as the ultimate interface. So I think bringing them together, controlling the virtual world by thought is still a very interesting challenge. And now it's an exciting time for us because with the proliferation of virtual reality consumer devices, there's so many amazing content people, filmmakers, animators that we can collaborate with and figure out this whole new challenges in what I call these dream machines or neurocinema machines. Thank you very much.